Atmospheric processes and energy exchanges are driven by Earth's energy balance and linked to climate and weather. Hurricanes, thunderstorms, tornadoes, blizzards, ice storms, dust storms, heat waves, as well as flash flooding resulting from intense precipitation, are all natural processes that are hazardous to people. These severe hazards affect considerable portions of Northern America and are responsible for causing significant death and destruction each year. But in order to understand topics such as thunderstorms, tornadoes, lightning, and hurricanes, we need to spend some time looking at the basics of weather. Warming up the atmosphere. Incoming solar radiation. The sun is the driving force of our weather and climate. Its diameter is about 865,000 miles or 109 Earths lined up side by side and is so large that it makes up 99.99% of the mass of our solar system. Our star, the sun, is the most common type of star in the universe and has existed for nearly 4.6 billion years. The composition of the Sun is about 92% hydrogen, the lightest element in the universe, and almost 8% helium, the second lightest element. Using these elements, the Sun generates energy through a process called thermonuclear reaction. This energy is created when the Sun fuses together hydrogen atoms to make a heavier element called helium. This process not only creates new elements, but also releases an enormous amount of energy. The energy emitted by the Sun is called electromagnetic energy, which travels at the speed of light in a spectrum of various wavelengths. Recall from the module on tsunamis that a wavelength is the distance between two wave crests, and frequency is the number of wavelengths that pass a given point in a given amount of time. The Sun's life expectancy is already half over, and in another 4 billion years it will consume all the hydrogen within it, leaving behind helium and a few other newly created elements. When the hydrogen runs out, in about 5 billion years, the Sun will grow into a red giant, expanding its diameter well past Mercury and possibly Venus and Earth. The Sun will continue to fuse helium into carbon until it begins to release its outer layers to form a planetary nebula. Left behind will be the white-hot core of our star, called a white dwarf, that will slowly fade out over billions of years,